So in this video, let's talk about how to draw the Lewis structure of F2, fluorine gas. So the first thing I'm going to do is write the number of the atom that I have and the number I have. So I have two fluorine atoms. Now on the periodic table, if you do not know how to get to the valence electrons thus far, I've made several videos that looks at how we actually get the number of valence electrons from the periodic table. So in this case, on the periodic table on the right side, you should see something like this. Now everything in the halogens column will give me 7 valence electrons, while everything in the noble gases column will give me 8 valence electrons. Now fluorine, obviously you could see, and the pattern goes on and on. So to the left it would be 6 valence electrons, again to the left would be 5 valence electrons, etc. So fluorine gives me 7 valence electrons. And so we need to go ahead and calculate the total number of electrons that we have. So this becomes 2 times 7, which becomes 14 valence electrons total that we have to place. So at this point, I could just go ahead and place two fluorine atoms together, and let's go ahead and form a single bond. If I form a single bond, then this is the simplest bond that I could form, so that's why I form a single bond. Now, fluorine is one of those atoms that must satisfy the octet rule. So we need to find some way to put the formula together where each fluorine atom satisfies the octet rule, and we still maintain the number of 14 electrons total. So if I go ahead and put Lewis dot structures around the fluorine atoms, let's see if this works. Right? We're just trying it out at this point, right? Could it be somehow a double bond? We don't know, right? But so far, let's talk about what we see thus far. Let's see if this works, right? So let's see if this satisfies the octet rule. So this becomes 2, 4, 6, 8. So this fluorine is good. If I do this, it becomes 2, 4, 6, 8. So this fluorine is good. So let's count how many total electrons we've used thus far, since we now know that the two fluorine atoms satisfy the octet rule. So this becomes 2, 4, 6, 8, 10, 12, 14. So this would be a plausible Lewis structure for the F2 molecule. Now, just as a point in going forward in your chemistry careers, usually if you have a halogen that's bonded to an R group, so let's say this is an R, and I have X, where X is the halogen, X will always look something like this, right? So keep that in mind going forward as you progress to organic chemistry, as you progress through general chemistry, and then eventually to organic chemistry, if you so choose to.